Bismillahirrahmanirrahim. Today we are going to discuss chlorofluorocarbons and ozone depletion with reference to environmental chemistry. Here we discuss what are these compounds, how they are responsible for ozone depletion, and finally the biological consequences of ozone depletion. Let's have a look at the introduction. Chlorofluorocarbons and hydrochlorofluorocarbons are fully or partly halogenated hydrocarbons that contain carbon, hydrogen, chlorine and fluorine. So they are produced as volatile derivatives of methane, ethane and propane. As in simpler alkanes, carbon has tetrahedral symmetry. The fluorine and chlorine atom differ greatly in size and effective charge. The methane-derived chlorofluorocarbons deviate from perfect tetrahedral symmetry. So, the physical properties of chlorofluorocarbons and hydrochlorofluorocarbons are tunable by change in number and identity of halogen atoms. In general, they are volatile, but they are less volatile than the parent alkanes from which they are formed. This decreased volatility is attributed to the molecular polarity induced by the halides, which induces intermolecular attractions or intermolecular forces. This was first manufactured in 1930s and industry soon found a wide variety of application for them due to their chemical unreactivity and heat absorbing properties. Chlorofluorocarbons and hydrochlorofluorocarbons have no natural source. They were first manufactured in the 1930s and due to the inertness, industries found a broad spectrum application as a refrigerant, degreasing agent and cleaning solvents. They invented it in 1928 and since then concentration of chlorofluorocarbon in the atmosphere have been rising. Due to the inert nature, they may remain in the atmosphere for 40 to 150 years. The most common representative of dichlorofluoromethane, which is also known as R12 or Freon 12, and its structure as shown in the figure. Now we are going to discuss the properties of chlorofluorocarbons and its subclass. Number 1. Chlorofluorocarbons and hydrochlorofluorocarbons are inflammable. Number 2. Chlorofluorocarbons and hydrochlorofluorocarbons are volatile but less than their parent alkanes. Volatile means the compound which evaporates at normal temperature. Number 3. Decreased volatility is attributed to the molecular polarity induced by the halide, which induces intermolecular interactions. Thus, methane boils at -161 degrees Celsius temperature, whereas the fluoromethanes boil between -51.7 to -128 degrees Celsius temperature. Number 4. Because of polarity, the chlorofluorocarbons and hydrochlorofluorocarbons are useful solvents. Number 5. The densities of chlorofluorocarbons and hydrochlorofluorocarbons are higher than their corresponding alkanes. In general, the density of these compounds correlates with the number of halides. Number 6. Chlorofluorocarbons and hydrochlorofluorocarbons are usually produced by halogen exchange starting from chlorinated methanes and ethanes. As in the following reaction, the chlorofluoromethane was synthesized from the chloroform. Here is the application of chlorofluorocarbons, which is well represented by the picture also. Chlorofluorocarbons are largely used as refrigerant, solvent, degreasing agent in the electronic industry, blowing agent in plastic formation, and propellant for aerosol canes. Billions of kilograms of chlorodifluoromethane are produced annually as a precursor to tetrafluoroethylene, the monomer that is converted into teflon. And as you know that teflon coated utensils are used worldwide, so you can well imagine how we are entangled between chlorofluoromethane and hydrochlorofluoromethane. Now, here is the most important aspect of the entire discussion, that is the discovery of environmental relationship of chlorofluorocarbons. Scientists initially believed that chlorofluorocarbons would be harmless in the Earth's atmosphere because of their chemical inertness. This inertness and their lack of solubility in water gives chlorofluorocarbons a long lifespan in the atmosphere, that is tens to hundreds of years, depending on the chlorofluorocarbon. In the late 1970s, scientists began to realize that chlorofluorocarbons do break down in the upper atmospheric region known as stratosphere and thus contribute to the depletion of the ozone layer. Stratospheric ozone shields life on Earth from the harmful effect of the ultraviolet radiation. The ultraviolet radiation induced breakdown release free and highly reactive chlorine and bromine atom from the chlorofluorocarbons. Several subsequent chemical reactions are kick-started by this process, including the breakdown of the stratospheric ozone layer. Even a small decrease in the stratospheric ozone concentration can result in an increased incidence of skin cancer in human beings and genetic damage in many organisms. In the following reaction, chlorofluorocarbon molecule dissociates in the presence of ultraviolet radiation into more reactive radical species with one or more unpaired electrons, and this reaction occurs in the stratosphere. The chlorine atom then reacts with ozone, initiating a process whereby a single chlorine atom can cause the conversion of thousands of ozone molecules to oxygen. Hence, ozone is depleted. Ozone depletion does not mean that a hole is created in the ozone. It means that the ozone gets thinner at any end from where ultraviolet radiation can easily damage life on Earth. Such conditions have repeatedly occurred over the Antarctic, causing the hole in the ozone layer. This picture represents the entire story from slide 8 to 10. In the picture, box 1 shows the emission of chlorofluorocarbons into the environment where they entered the ozone layer. Box 2 delineates what is going on in the ozone layer in the presence of sunlight having high intensity ultraviolet radiation. Box 3 shows the arrival of harmful radiation on Earth. Nowadays, chlorofluorocarbons are recognized as harmful chemicals because of their ozone depletion properties. Slide 12 represents the short-term effects due to the depletion of ozone layer by chlorofluorocarbons. Inhalation of higher concentrations of chlorofluorocarbons can cause the symptoms of number 1, intoxication, number 2, reduced coordination, number 3, lightheadedness and headache, number 4, tremor and convulsion, number 5, irregular heartbeat, number 6, frostbite on the skin and in the upper airways. This slide shows long-term health effects. Depletion of ozone layer due to chlorofluorocarbon creates dangerous environmental effect and increases exposure to dangerous ultraviolet rays, which can cause number 1, cataract as shown in the eye of this beautiful kid, number 2, weakened immunity system. Number 3, skin cancer. In the 1990s, 93 nations agreed as a member of Montreal Protocol established in 1987 to eradicate the production of ozone-depleting chemicals by the end of the 20th century. Because of a growing concern over stratospheric ozone depletion, a ban was imposed on the use of chlorofluorocarbons in aerosol spray dispensers in the late 1970s by the United Nations, Canada, and the Scandinavian countries. By 1992, the list of the participating countries had grown to 140 and the timetable for ending production of chlorofluorocarbons advanced to 1996. This goal has largely been met. Hydrochlorofluorocarbons pose less of a risk than chlorofluorocarbons because they decompose more readily in the lower atmosphere. They also degrade the ozone layer and are scheduled to be phased out by 2030. At the end, just for the general knowledge, I want to explain the Scandinavian countries. These are Nordic countries, include Finland, Iceland, Norway, Denmark, Sweden, and the Faroe. These countries share similar flag, language, and many cultural traits. And Faroe Islands are autonomous country within the Kingdom of Denmark. Slide 16 again illustrates the topic. Slide 17 caters a video represent the entire discussion. This will help you more. So this is all about chlorofluorocarbons and environment. May Allah bless you and entire Muslim Ummah. Keep pray for everyone. Thank you.
15 to 35 kilometers above Earth's surface, a gas called ozone surrounds the planet. The ozone layer acts as a barrier between Earth and ultraviolet radiation from the sun. However, pollution has caused the ozone layer to thin, exposing life on Earth to dangerous radiation. Earth's atmosphere is made up of 6 layers. The second layer, called the stratosphere, contains the ozone layer. The ozone layer is made up of a highly reactive molecule called ozone, which contains 3 oxygen atoms. Ozone is a trace gas in the atmosphere. There are only about 3 molecules for every 10 million molecules of air. But it does a very important job. The ozone layer acts as Earth's sunscreen, absorbing about 98% of damaging ultraviolet or UV light. But the ozone layer has gotten thinner. Chemicals called chlorofluorocarbons, or CFCs, are the primary culprits in ozone layer breakdown. A CFC is a molecule that contains the elements carbon, chlorine, and fluorine. CFCs are mostly found in refrigerants, aerosols, and plastic products. When CFCs are exposed to ultraviolet rays in the atmosphere, they break down into substances that include chlorine. The chlorine reacts with the oxygen atoms in ozone and rips apart the ozone molecule. Areas of damage in the ozone layer are often called ozone holes, but that name is misleading. Ozone layer damage is more like a thin patch, with the thinnest areas near the poles. The ozone layer above the Antarctic, in particular, has been impacted by pollution since the mid-1980s. There, the region's low temperatures speed up the conversion of CFCs to ozone-damaging chlorine. About 90% of CFCs currently in the atmosphere were emitted by industrialized countries in the northern hemisphere. In 1989, the Montreal Protocol banned the production of ozone-depleting substances. Since then, the amount of chlorine and other ozone-depleting elements in the atmosphere have been falling. Scientists estimate that chlorine levels will return to their natural state in about 50 years. By then, the Antarctic ozone hole will shrink to